I'm Steve King with 3M Communication Markets Division. I'm an applications engineer, and I'm here to introduce 3M's Mobility Solutions Tower Solutions platform. Now, as you're probably aware, with the emergence of the data-intensive 3G and 4G services, we see considerably more drive towards tower-mounted electronics, specifically tower-mounted radio equipment. This is important for a couple of reasons, one of which is advanced antenna systems such as MIMO or MIMO, which are required to achieve the signal-noise ratio required to achieve the data rates that we are attempting to achieve. And just for your information, for LTE, the standard would be 100 megabits per second of data to a mobile user with 1 gigabit per second to a stationary user. So that sort of change has driven a paradigm shift in the way that the architecture at the tower has evolved. So just beginning to explain how this is handled in the tower infrastructure system, let me start with the cabling that now runs up to the tier where the remote radio head would be located. Basically what we have is a trunked fiber cable, in this case carrying 12 discrete fibers, which can be connectorized either on the ground with mechanical field mount connectors or actually up on the tower in a very simple process. They can be hosted in this bank of fiber optic adapters. Generally speaking, duplex LC is the standard, and from that point a jumper connection with 2 fibers can be taken out through these reusable port plugs. So the port plugs can be removed up on the tower, and the actual seal for the cable is accomplished with this ECAM port. And the ECAM port has got a rubberized grommet on it which provides a hermetic seal. So this is the 3M Tower Dome solution, and it's secured with a lanyard. It has a permanently mounted O-ring on the bottom, and it has a closable bail which is permanently mounted to the dome itself. In addition to this, we also have solutions for the tower to manage the power as well as the fiber optic cable coming up the tower. So in a situation where perhaps you have conduit that's running inside of a monopole, we have this solution, which is our tower top enclosure, which basically allows you to manage the fiber cables that come up with a fiber spool, and you have entry and exit ports that mount directly to interduct type conduit fittings for moisture-proof, environmentally secure connections. But this also features some very strong strain relief and strength retention for the power cables. Now keep in mind that the power cables do not have low weight. They're significantly high gauge. So what we provide is hooks for the Kellum griffs, which you hoist the cables up with, and then these hooks can each support 250 pounds individually. So the idea would be this is a locus point for all of these cables to come out, and then you can go to the dome terminal for the actual access and drops to the remote radio head itself. In addition, the 3M solution set also includes these universal general purpose mounting brackets, which are very rugged and suitable for the tower use. And notice how the dome mounts directly to the mounting bracket with its swing away arm. We also provide these mounting buffers or clamps for the cables as they go down. And just to forestall some incorrect practices in the industry, stainless steel tie wraps are not the best method for securing fiber optic cable to the tower. The tower does tend to vibrate, so a solution like this with shock bumpers and actually allowing some vertical play on the cables and yet not physically tying them to the tower assembly itself directly are much less invasive and much less prone to cause shearing or breakage of the fiber optic cable. So proceeding around the other side of the tower, we'll start with the remote radio head. Now the remote radio head connects to the multi-band or multi-service antenna via 2 or more half-inch coaxial jumpers. Now these coaxial jumpers require weatherproofing solutions to basically seal them out from moisture, and that can cause PIM-related type of effects. So our new solution in this area is our so-called small form factor closure, which we believe to be the smallest in the industry. It basically can accommodate 7/16" DIN connectors on a 50 millimeter or 2-inch center-to-center spacing. That means that you can get 2 of these closures on 2 adjacent RF connectors as long as you hold a 2-inch minimum center-to-center spacing. And so this is very eagerly anticipated in the industry, and I'll show you a bit more on that in just a moment. But for solutions that still use the hardline coax, we also have solutions such as our cold shrink tubing, which would allow you to get a weather-tight seal with either silicone or EPDM rubber. No heat required, very simple to install. So we have solutions for the legacy hardline coax, as well as you can see, the fiber to the tower applications. Moving over to the weatherproofing side of things, 3M has been in weatherproofing in mobility applications for 10 years or so. We started, of course, with our well-known tapes and mastics series, which are still very commonly used in the infrastructure for coaxial-based installations. A while later, we introduced our pull and shrink tubing. This innovative solution allows you to get a weather-type seal simply by pulling out the internal ripcord and seeing the pre-stretched tubing basically close down over the joint in question. This is available in both silicone and EPDM rubber bases and in multiple sizes. So you can see various samples indeed on the tower as well of, say, a 1 5/8" connector reducing to a 1/2" connector sealed by our pull and shrink tubing. But eventually, in order to accommodate the need for re-entry, we developed a line of closures, the re-entrable closures, generally speaking, one-handed operation that would allow you to hermetically seal a joint for a coaxial cable plant and yet reopen it if you needed to gain access for something like PIM testing. We have our OSCW series, one-step closure for wireless, which basically has an innovative proprietary gel component inside it. It closes over and latches. It's a simple one-piece part, can be done with one hand. This would be an example of a 7/8" feeder cable, which was basically would be running over to a 1/2" jumper. You simply close the closure over the jumper assembly itself, latch it closed, and you're finished. As I mentioned before, as the services improve to LTE and advanced 3G, we start to see new antenna technologies taking root. And these are multi-band, multi-service, multiple in, multiple out type of antennas. That means more RF feeds at the bottom of the antenna with limited spacing, because antennas cannot just grow to superhuman sizes due to wind load factors. In order to meet that need, 3M is about to introduce the new small form factor closure. This unique closure has the minimum spacing of any closure on the market, and it incorporates a proprietary gel webbing structure. Operates about like this. Once again, a one-handed solution. Goes around the 7/16" DIN nut itself, closes and latches, and then with a simple operation, the technician simply brings up the closure, slides it into place, and the locking tab clicks into position. When he's ready to re-enter for, say, some sort of periodic maintenance or PIM sweeps, he simply removes the closure, overmolding, and then undoes the latch and exposes the connector again. This is quick and easy, and it facilitates routine maintenance in a very simple way for standard type of testing, such as PIM testing on these high-gain, advanced type of networks. As I was mentioning, one of the new trends in the fiber to the antenna is to actually do field termination of fiber optic cables. This turns out to be very much in keeping with the historic methods of deploying coax-based systems. If you go back, when tower hands were deploying coax-based transmission systems, they would roll out a spool of coax and they would crimp on a connector to length, thereby exactly matching the cable length with the size of the tower. As the industry began to evolve towards fiber-fed systems, the initial response was to use factory terminated or pre-terminated fiber optic connectors. And that was primarily due to a lack of familiarity with the characteristics of fiber optic cables. However, recent developments have shown interest in doing field termination of fiber optic cables, thereby eliminating the two worrisome issues of excess slack storage or, more importantly, cables that are too short. 3M offers a number of products in this solution space. They're featured here on this display. We have our NPC series, or no polish connector, that feature a pre-polished ferrule with a short stub of fiber inside with index matching gel and a mechanical splice element. We also have our Crimp Plus connectors, which have no internal splice, but they do have an innovative polishing mechanism that's easy to perform in the field, and it's very simple to operate. So my colleague here will demonstrate how quick and easy it is to perform a fiber optic splice with the NPC LC mechanical splice in the field. As you can see, when the fiber bows, the splice has reached the adequate tension, the splice is actuated, and then the buffer clamp is then engaged to basically hold the fiber jacketing in place, achieving approximately a 4-pound pull-out rate, which is significant for this type of mechanical splice. So what we're actually seeing is that with these very simple, low-cost tools and a simple cleaver, that you can actually affect fiber optic splice in low fiber counts. Typically the types used on a cable might be 12 fiber cable, 24 fiber cable. You can achieve these once you've had a little bit of practice in maybe 2 minutes per splice, thereby eliminating the extra cost and overhead of having pre-terminated cable assemblies of multiple different lengths and, more importantly, the wrong length. So this is an important development in this space, and we're very excited about the possibility for it to enhance and speed up the deployments of LTE infrastructure. 3M Mobility Solutions also includes a significant number of solutions that are tailored for the cell site backhaul. Specifically, we like to concentrate on the point of presence. That would be the area where the fiber optic backhaul provider would drop off the fibers to the individual wireless operators. So we have a number of solutions, one of which is our 8924, which is very commonly found in the field now. It includes, as you can see, an area for splice case that's protected entrance, thereby giving you craft separation with a separate key lock so that only the backhaul provider can get into the splice case and do the rearrangements there. On the customer side, you have yet another lockable door which exposes the terminals. Each of these terminals would be an individual removable fiber optic connector that would be a drop to the cell site or to the base station equipment. In addition, we also have terminals that are more explicitly designed for the smaller counts that often occur at base stations. This case, we would have a splice case where you would have one conduit entry port in, size for 3/4 inch conduit. It goes to a 3M 2522 splice case and then exits on a single drop. That would be for a single provider at a location. Alternatively, we have solutions, multi-port solutions, that would allow you to come in with, say, a 24 fiber entry cable, hit a splice case, have multiple exit terminations or drops, each one going to a separate provider or to a different location, say it be enterprise or business. And of course, all of these are lockable terminals and suitable for field use and mounting outside on H-frame or on the pole. So further in our backhaul solution space, we have a number of different types of splice closures and terminal closures. And so basically, these 3M fiber dome units are designed to be buried half grade in a manhole or a hand hole. They're fully sealable IP68 integrated gasket. They have the ability to have express cables or field terminated cables directly into them. And they also utilize our innovative eCam port assembly for drops. So you can use these either as splice closures or as terminal closures, thereby providing the fiber drop to, say, a cell site from outside the fence, for instance. We have these in many different shapes and sizes. But while we're talking about the different shapes and sizes, I'd like to just elaborate a little on our 10-inch dome, which we've incorporated as a combined hybrid power and fiber optic solution for the tower. Now, with this particular dome, you can see that we've achieved some craft separation by putting the fiber optic connectivity on one side of the mounting plate, whereas the copper connectivity for the power connections is on the other side. In this particular instance, this solves one problem that you often see on the tower, where you have very large gauge, say 6 AWG, that's going up the 150 feet to the tower tier, but then you need to transition to a lighter gauge, say 12 AWG, to go to the remote radio head for the last 15 feet. This terminal block accomplishes that. It's easy to access. The cables are mounted in from the bottom. You just add these drops as you go. Once again, in the same paradigm as we had on the tower, the eCam ports can provide connectivity and a re-enterable solution for power or fiber. We also have solutions that would integrate the fiber connectivity with surge suppression. By incorporating an industry standard DIN rail, we're able to use standard surge suppressor modules, which you can add incrementally. So you can provision this for, say, your minimum configuration up front and add surge suppressors up to as far as you can go with the available space within the dome. Once again, the dome can be grounded through this copious number of ground lugs and uses the eCam ports for entry and exit. 3M Tower Solutions for the complete platform for your evolution to LTE and 4G networks. We contain everything from the infrastructure, fiber connectivity, cable management, and weatherproofing. One-stop shopping. Call 3M.